All right, in our last example, we're going to be given a point and we need to prove if it's on the same circle. So in this example, it says prove or disprove that the point root 2 lies on the circle centered at the origin and containing the point 2, 0. So a lot of information is given here, but let's break it down, okay? Let's say, for example, we have a circle. And in this circle, we're going to create our Cartesian plane. And let's go ahead and identify the things that we know about this circle. In this circle, it is centered at the origin. Okay, cool. So if it's centered at the origin, this means that this center is located at 0, 0. And it contains the point 2, 0, 2, comma 0. So 2, comma 0 would be like what? 2, 0? So like right over there. This would be 2, 0. Okay, cool. So what we need to do here is we need to find out, is this point root 2 comma root 2 also going to be on this circle? Just for the purposes of this, what is root 2 going to be anyway? Root 2 is the same thing as 1.414. So about 1.4. So is 1.4 going to be on this circle? That's what we're going to try to find out. All right. If we wanted to find that out, the first thing that we need to find out is the radius, because all of the points on the circle will be that radius far apart. Okay. So if we wanted to find that, we need to find the radius between 0, 0 and 2, 0. I'm sure you're just wondering, oh, you could just count 2 units. That's totally fair. Okay, so let's do that then. So here, it's just 1, 2. So the radius is just 2. In this next example, we're going to show you how to find the radius, but we already know how to find the radius between the center and the edge of it. We just use the distance formula. But the radius here is simply just 2. Okay, so what that means is, since the radius is 2, this point right over here, this root 2 comma root 2 also needs to be a radius of 2 units away from the circle. It only makes sense. So if we wanted to do that, we need to use the distance formula. The distance formula, again, df means distance formula, is the square root of the difference of our x value, so x sub 2 minus x sub 1 squared, plus the difference in our y values, y sub 2 minus y sub 1 squared. So let's go ahead and substitute these values. In order for us to do that, we need to identify what our 2 points are. So let's say that our center of 0, 0 is our first point, and then our second point is this 2, 0. So we'll say point, oh, no, not 2, 0 actually. Our second point is root 2, root 2. My bad. Root 2 comma root 2. All right, let's go ahead and substitute these values. So the distance formula is equal to the square root of, so our x sub 2 is our second x value. So if this is our x and our y, so it's going to be root 2 minus 0 squared plus, what is our y sub 2? It is our second y value, which is our root 2 again, minus 0 squared. All right, let's go ahead and just simplify this. Root 2 minus 0 is just root 2. So we have root 2 squared plus root 2 minus 0 is, again, root 2 squared. So root 2 squared. So root 2 times root 2 is the same thing as root 4, which equals 2. So root 2 squared is just 2. So the square root of 2 plus the same thing again, plus 2. So root 4, which equals 2. So because root 2 has the same radius, this is going to give us the distance, which gives us the radius, right? So 2 is the radius here. So if this 2, 0 was also 2 units away, and this right over here, this root 2 comma root 2 is also 2 units away, that means that root 2 comma root 2 is on the circle. So we can say now that because the radius is also 2, because r also equals 2, root 2 comma root 2 is on the circle. Awesome. So let's go ahead and use that same logic for this next example. Prove or disprove that the point 1 root 5 lies on the circle centered at the origin and containing the point 0, 1. So it's the same idea here, but just different numbers, okay? So I'll walk you through this one. Lots of information. So again, it always helps to sketch it out. I will draw a circle first with my y-axis and my x-axis. So what do we know about the circle? It is centered at the origin. I'll use different colors here. Centered at the origin. So that means that this center is located at the 0, 0, and it contains the point 0, 1. So 0, 1 is going to be like right over here. If it contains the point, that means that it's on that circle, right? So that means that it's on this edge. So that's 0, 1. All right, let's see what this radius is. Easily, we could see that the radius is 1 unit. But what if we didn't know what the unit is? Let's just say, for example, we don't know where that is. We can use the distance formula. So the distance formula is just going to be, again, that x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And then let's go ahead and substitute these values. I'll say that my center 0, 0 is our first point. And then we have that other point 0, 1. So I'll just substitute these values, okay? So x sub 2 is going to be 0 minus 0 squared plus y sub 2 minus y sub 1. So that's this right over here, 1 minus 0, 1 minus 0 squared. So now we have 0 squared plus 1 squared. 0 squared is just 0 plus 1. So we have the square root of 1, and the square root of 1 is just 1. So that means that the radius, like I said, equals 1, okay? So if we substitute these values with 1 and root 5, and if we get the radius back as 1, that means that 1 root 5 is also going to be on that circle. So let's try that out. 1 root 5, is that on? Let's see if it gives us the same radius. So again, our center is 0, 0. And then the test that we're going to, the point that we're going to test out is 1 root 5. All right, let's substitute these values. So x sub 2 is our x value of our second point. So 1 minus 0 squared plus y sub 2 minus y sub 1. So our y sub 2 is our root 5. So root 5 minus 0 squared. So good thing we have some easy numbers to work with. All right, 1 minus 0 squared is just 1 squared plus root 5 minus 0 is just root 5 squared. So now we have 1 squared, which is just 1, plus root 5 squared is the same thing as root 5 times root 5, which is the same thing as root 25, which is just 5. Okay, so that's always the shortcut here. So whenever you square something like this, it's just what's inside the denominator. Oh, it's inside the radical, not denominator. Whoopsies. Plus 5. All right, and then 1 plus 5 is the square root of 6. But this is our radius then. That is the distance. This is the distance right here. Root 6 is the distance between the center of a circle to whatever the circle is supposed to be, right? But since the original radius is 1, and the radius that we got when we inputted here for 1 root 5 is root 6, since 1 does not equal root 6, that means that the point 1 root 5 is not on that same circle because the radii are different. Okay, that's it. Bye.